In a mixing problem, what you're going to do is track the amount of a substance in a tank over time. Suppose a tank initially contains 100 gallons of pure water. Brine containing 2 pounds per gallon of salt flows in at 3 gallons per minute, and then the mixture flows out at also 3 gallons per minute. What we want to do is set up and solve the differential equation for the amount of salt that we're going to call y of t. We can then use our solution to find the amount of salt after 20 minutes. The differential equation for the amount of salt is going to be the rate of change of the salt is equal to some quantity. So let's write down dy dt, that's the rate of change of the salt. It is going to be equal to the rate in minus the rate out. That just means it's going to depend on the salt per minute in minus the salt per minute out. And that's what we have to figure out. Let's look at the rate in first. We are told that brine is flowing in, and that has a concentration of 2 pounds per gallon. And it's flowing in at a rate of 3 gallons per minute. So we're going to multiply this by 3 gallons per minute. And this is equal then to 6 pounds per minute. Now let's look at the rate out. We are not told how many pounds are flowing out because that's what we want to find. So the amount going out, we're going to say is the amount of salt per gallon. And we're told that it flows out at 3 gallons per minute. I'm going to highlight this because I think that's the hardest part. Now we can decide what the salt per gallon is equal to. The salt is our variable y, and our tank holds 100 gallons of water. So we're going to divide y by 100. This gives us 3y divided by 100 pounds per minute, because y is in terms of pounds. Let's now put this into our equation. We have dy dt is equal to our rate in, which we found was equal to 6, minus our rate out, which was 3y divided by 100. Let's highlight this because that is our differential equation, and we need to add a condition to that. We are told, let's look back up here, that initially the tank contains pure water. That means the amount of salt initially is 0. So we can say down here that y, which is the salt, at time 0 is equal to 0. And there's our initial condition. Now we are all set to go ahead and solve this differential equation. Let's rewrite the right-hand side, and I think when we do that, we'll be able to tell what type of equation we're working with. Let's rewrite the right-hand side as 600 minus 3y divided by 100. Now you can see that we are working with a separable differential equation. So let's go ahead and let's move all the y's to the left and the t to the right. This gives us dy all divided by 600 minus 3y is equal to dt divided by 100. Now we can go ahead and integrate both sides. On the left, we have a minus 1/3. That is because the derivative of y is minus 3. And we have a natural log, absolute value 600 minus 3y. And then on the right, we just have 1 divided by 100 times t plus an arbitrary constant that I'll call c1. Let's multiply both sides by minus 3. So on the left, we have natural log 600 minus 3y. And then on the right, we have minus 3 over 100 times t minus 3c1. We can now exponentiate both sides of our equation. On the left, the e and the natural log are going to cancel out. So on the left, we're just left with 600 minus 3y. And on the right, we have e to the minus 3 over 100 times t. And then let's write this and split up the exponential like this. Now let's get rid of the absolute value. So we're going to get a plus or minus, and we're going to put that on the right-hand side. So we have plus or minus, and I'm going to change around our exponents. I'm going to write this one first, and then I'm going to write the next one. The reason I'm doing that is we can now call this constant C2, and then we can solve for y. Let's first write 600 minus 3y is equal to C2 e to the minus 3 over 100 times t. Let's pull the 600 over to the right. So we have minus 3y is equal to C2 e to the minus 3 over 100 times t minus 600. And then we'll divide by minus 3. And we get y is equal to C2 divided by minus 3 times e to the minus 3 over 100 times t plus 200. Let's rename our constant once more. We'll call that c. And over here on the left, we can write down our solution. Y is equal to 200 plus c times e to the minus 3 over 100 times t. Now we need to solve for c, and we can do that by using our initial condition that y of 0 was equal to 0. So let's plug in that t is equal to 0. This gives us y is equal to 200 plus c times e to the 0, which is just 1, and this is equal to 0. So this tells us that c is equal to minus 200. And we can write our solution as y is equal to, let's see, they both have a 200. So I'll pull that out, and we have 1 minus e to the minus 3t over 100. And there's the solution to our differential equation. Now we also need to put units with this. Y is the amount of salt, and the amount of salt is measured in pounds. So let's put pounds over here. The second part of our problem is to find the amount of salt in the tank after 20 minutes. So that means we need to find y at 20. Let's write down what we had for our y of t. It was 200 times 1 minus e to the minus 3t over 100. Now all we have to do is let t be equal to 20. This gives us 200 times 1 minus e to the minus 60 over 100. And this is just 200 times 1 minus e to the minus 0.6. You can put that in your calculator, and we find that our answer is approximately 90.24 pounds. So we now know that the amount of salt in the tank after 20 minutes is 90.24 pounds. And that's all there is to solving mixing problems. If this video has been helpful to you, please consider subscribing to my channel. Keep believing in yourself and have a great rest of your day.